So here, this is flip-flop. Let's look at how we can define this. There are inputs, data, clock, reset, and there are outputs, Q bar. So here, inputs, output. So here I'm planning to use always. So I'm defining the output as a range. Don't assume anything. We are using range because we want to infer flip-flop. No, it doesn't work like that. The hardware doesn't depend on constructs. The hardware depends on coding style. So you need to focus on coding styles here. This is the rule. We are using always block, so the output has to be range. Here, if you look at Q bar is not range because we want to use assign. Let's look at the functionality. Always at passage clock. So this is going to infer flip-flop. Whenever you include clock in the sensitivity list, obviously it will infer flip-flop. If reset is high, the output gets 0, else output gets data. This is how you can define D flip-flop. And whenever Q changes, we want to toggle Q bar, right? So we are using assign. Q bar equal to not of Q. So whenever event happens on Q, automatically it produces Q bar. And always and assign, these two are concurrent blocks. We can visualize like this. So these two blocks will happen at the same time. Whenever Q changes, at the same time Q bar also changes. Both the blocks will happen at the same time. Here, we are using clock in the sensitivity list, so obviously we are going to get flip-flop. Let's look at asynchronous clear. What we have seen synchronous. Module, almost everything is same except sensitivity list. D flip-flop, asynchronous clear. All the ports, inputs, output. We are defining output as range because for Q we are using always block. And for Q bar, we are using assign, almost same. Only the sensitivity list differs. Again, to define sensitivity list, look at the diagram. So here, clock has bubble, which means clock is active low. So instead of passage clock, I have to say negate clock. Remember this. So here, clock has bubble. So I am defining it as negate clock, comma, negate clear. So here clear is asynchronous, so it has to be part of sensitivity list. And clear also has bubble, so we have to say negate. Now, there is one important point. You say negate clear doesn't mean that the clear is going to be edge sensitive. You take any flip-flop, only clock is edge sensitive and remaining signals will be level sensitive. Whether it's reset or clear, everything is going to be level sensitive. But in Verilog, the syntax looks like this. But you have to remember this. Negate doesn't mean that the clear will be edge sensitive. Here, clear will be level sensitive, but clear is active low. To define active low, we have to say negate. This is something important you have to remember. Okay. If clear is active low, so not of clear. Whenever clear becomes 0, then the condition becomes true, then Q gets 0. You have to visualize like this. Else Q gets D. This is how we produce Q. Whenever Q changes, Q bar also changes. So Q bar equal to not of Q. So here one important point is the clear is asynchronous, so it has to be part of sensitivity list. And clear is active low, so it has to be negate clear. It doesn't mean that clear is edge sensitive. Still it's going to be level sensitive.
Thanks for watching this video. Thank you.